So feel welcomed. Remember to subscribe if it's your first time, then also to share with your colleagues. So under curve sketching, the first thing is to note the key elements. So you are first supposed to find the turning points so that you will plot the turning points. Find the x-intercept of that curve so that you will also plot it. Then find the y-intercept so that you will also plot the y-intercept points. Getting those points, which will be 4 and above, will give you the exact curve to be sketched. If this is the function of that curve, we first find the turning points. How do you find the turning points? Remember, at turning points or at stationary points, the gradient function is normally equals to 0. Therefore, we differentiate this one 1. So differentiating once, remember in differentiation, is simply the power multiplied by the coefficient, then we raise the power by 1. That gives you 3x squared plus 10x plus 3 is equals to 0. So it is a quadratic function which, when simplified, using the equation or the quadratic equation, which is normally, actually I have not written, but it's normally x is equals to negative b plus or minus the square root of b squared minus 4ac, the whole of it being divided by 2a. So that it now gives you negative 10 plus or minus 8 divided by 6. So that our x1, when choosing addition, it gives you negative 10 plus 8 over 6, which is negative 1 over 3. And our x2, when choosing subtraction, it gives you negative 10 minus 8 over 6, which is 18 over 6, or negative 3. And therefore, we are also supposed to find the y1, which corresponds to the x1. Remember, you simply substitute the value of x1 in the original function, which is given by y is equals to this one. So therefore, you end up with a third cubed plus 5 in bracket negative a third squared plus 3 in bracket negative a third is supposed to be negative a third minus 9, which leaves you with negative 9 and 13 over 27. That point becomes negative a third, negative 9, 13 over 27. Then for y2 again, you substitute the value of x2 here in the original function, which will leave you with 3, 0 as that point, because the value of y will be 0. So therefore, from the turning point, we now have this one point which will be plotted, and also another point here that will be plotted. So we now move on to our second point. The second point is to find the x-intercept. Remember, for x-intercept, you normally say that the value of y is normally 0. From this sketch, that if this one is a curve, so when any point is on the x-axis, the value on the y-axis is normally 0. Therefore, we say that at x-intercept, the value of y is normally 0, so that you now replace 0 here. Replacing here 0, we equate this curve to 0. So when you equate this one to 0 here, it shows that this one is supposed to be equated to 0, but it is still a cubic function, so you're supposed to reduce it to a quadratic function. So you first choose any value that can be substituted here to give you the answer as 0. So for my case, I've found that when you replace this one with 1, so it becomes 1 cubed plus 5 in brackets 1 squared plus 3 in brackets 1 minus 9 will give you 0. Therefore, my x1 becomes 1. So collecting the 1 to the other side to equate to 0, you get that x minus 1 will be the first origin to be used for division. So therefore, dividing the original function, this one, by x minus 1. So remember, when you are dividing, you place here any value. For example, you place here any value to be multiplied by this one to produce a required similar answer here. So when you choose and substitute here with x squared, it becomes x squared times x, which now becomes x cubed, then times negative x, which will give you negative x squared. Then you subtract here. So when you are subtracting, x cubed minus x cubed becomes 0. So 5x squared minus x minus x squared becomes 6x squared. So then you drop the others. Again, you ask yourself a number that can be replaced here, so that when you multiply by this bracket, will give you the first value as 6x squared. So replace with 6x. 6x again, when you multiply by this one, will give you positive 6x squared minus 6x. So that under subtraction leaves you with negative 9x, with positive 9x minus 9, so that you now place here 9 to be multiplied by this bracket to give you 9 minus x. When you subtract to get 0, then that means that this value here, the quotient is the quadratic equation, so that you also factorize it and get that the value of x1, x2 is negative 3. So x2 is negative 3 and also x3 is also negative 3 from this substitution or factorization here. So you also have 2 points to be plotted, that is 1, 0 and also 3, 0. So that after getting this value of x, remember our x1 is 1. So substitute 1 in this function to get y1, which will be 0. Then also negative 3x, which will also give you 0. Then the last step is now to find the y-intercept. So y-intercept also x is normally 0. So you now substitute here when x is 0 and get that the value of y is 9. So you now have our last point to be plotted as 0, 9. So therefore all the points now are here. Remember this one were from the x-intercept, this one is from the y-intercept, this one is from the turning points. So you choose a suitable scale, then plot. Remember my first value, for example 1, 0 is now this one, negative 3, 0 is this one, 0, 9 is this one, then negative a third, negative 9, 13 is this one. So when you are drawing, you join the x-intercept to y-intercept, y-intercept to x-intercept, then to the turning point, then complete with the other point of x-intercept to form a sketch of the curve. Then from there, you must indicate the name of that curve there to complete your work. Remember to subscribe and share with your friends, and any point that you have any information, maybe any comment, simply drop it there for the purpose of improvement. Thank you.